Today we will discuss the electrostatic potential energy due to an external electric field. Okay, potential energy due to a external electric field. Due to an external electric field. Okay, let us consider this is an external electric field having strength E. Okay, let us consider as far as Q is at infinity. Clear? We have to bring this charge. From this point to some point P at the external electric field. Now we have to find the potential energy U at this point. Okay? Therefore, we can assume the R dash is the position vector of point P. Okay, R is the position vector of point P. Therefore, since there should be some charges, there is system of charges, therefore for that case here should be a potential, total potential, and that potential at position vector R is VR. Okay, what is the value of VR? We should not need to do that. Only potential at point P is VR, where R is position vector. Okay, now we have to bring this charge from infinity to point P, where potential is VR. We know that work done by charge is equal to what? Potential. Okay, that is what. So work done is equal to potential into charge Okay, work done is equal to potential into charge. Clear? Therefore work done W is equal to VR into Q. This work done will be converted into potential energy. Okay, so we can write, let us consider an external electric field where P is any point, a surge Q is at infinity, and we have to bring the surge from infinity to point P. Okay, R is position vector of point P. Therefore potential at point P is VR. Potential at point P is VR. Okay, write down. Therefore potential at point P is VR. Now work done, W is equal to VR into Q. Okay, this work done is stored as potential energy stored as potential energy. Therefore U is equal to UR is equal to VR Q. Okay, clear? So VR is equal to UR by Q. Okay, for unit charge that is Q is equal to 1 coulomb, VR is equal to UR, that is potential is equal to potential energy when Q is 1. Clear? This is the potential energy due to an external electric field. This is okay. Fine. Next, now one electron is moved through a potential of 1 volt. Then total potential energy U is equal to what will happen? VR into Q. U is what? Potential energy. V is what? How much? 1 volt. What is the electron? Electron is moved through the what? Potential of 1 volt. Therefore, charge of 1 electron is 1.6 into 10 to the power minus 19 coulomb. Therefore, 1.6 into 10 to the power minus 19 what? Potential energy is what? Joule. Okay, this is the potential energy of the electron. Clear? Now this is equal to 1 electron volt. 1.6 into 10 to the power minus 19 joule is 1 electron volt. Okay, 1 electron volt is equal to 1.6 into 10 to the power minus 19 joule. Okay, now 1 million electron volt is equal to 1.6 into 10 to the power minus 19 joule into how much? Million means 10 to the power 6. 10 to the power 6 what? Joule. So its value is 1.6 into 10 to the power minus 13 joule. So 1 million volt is equal to how much? 1 million volt is equal to 1.6 into 10 to the power minus 13 joule. Clear? Okay, fine. So you just keep in mind that 1 electron volt is 1.6 into 10 to the power minus 19 joule and 1 million electron volt is 1.6 into 10 to the power minus 13 joule. Okay, now the next topic is potential energy of a dipole when it is dipole in an external electric field. external electric field. Okay, potential energy of a dipole in an external electric field. Clear? Let us consider this is uniform external field. Okay, this is what external electric field of strength E. Now a dipole is placed here. This is minus Q, this is plus Q at a distance twice A. This is center of dipole. Okay, this is force how much? QE minus QE, F is equal to plus QE. Okay, now this dipole is make an angle d theta, okay, that is angular rotation is how much? D theta. Okay, let us consider an electric field of strength E, where a dipole of length twice A and dipole moment P, where a dipole of length constant moment P is placed. Okay, therefore total torque experienced by the dipole is torque is equal to P cross E, that is PE sin theta. Okay, so we can write like this and vector PE sin theta. Clear? Okay, now the dipole is rotated by d theta angle. Okay, as in diagram. Therefore work done dw is equal to torque d theta. Okay, work done is how much? Torque into d theta. Torque means torque is same as force in linear motion. Torque is in rotational motion, and d theta is the same as linear displacement dx. D theta is angular displacement. Okay, therefore work done is equal to force into displacement. Work done is equal to torque into angular displacement. Okay, torque into d theta. Okay, so if initial angle, this is the direction, so this is the initial angle theta 1 and this is the final angle theta 2, then work done dw is equal to theta 1 to theta 2. Okay, therefore Therefore, theta 1 to theta 2, torque is how much? PE sin theta into d theta. Okay, write down. Okay, so you can write there is a, this is W, okay? W is equal to, since dW is equal to torque into d theta, therefore work done is equal to integration over dW theta 1 to theta 2. Okay, please write down. This is before, please. Okay, write down. So theta 1 to theta 2, this after this value should be placed. Therefore work done is equal to, P is constant term here, P is constant term, so it will come up from the integration. Now sin theta d theta. Okay, so PE, what is the value of integration over sin theta d theta? That is minus cos of theta. So its value is from theta 1 to theta 2. So PE minus cos of theta 2 minus cos of theta 1. Okay, so we can write minus PE, minus sign is out, so cos of theta 1 minus cos of theta 2. Sorry, okay, fine. No, this value should be like this. Okay, so minus C is minus cos theta 2 is here, minus, and so this value should be positive, minus of minus. Okay, so cos of theta 1 minus cos of theta 2. Clear? If theta 1 is equal to 90 degree, if initially, if this is like this 90 degree and it's rotated like this, if theta 1 is 90 degree, then work done is equal to PE minus cos of theta 2. Okay, so minus PE cos of theta 2. This is what work done. Okay, why this is happening? So work done is equal to PE cos of 90 degree minus cos of theta 2. Okay, after this cos theta is equal to cos 90 is equal to 0, so this will be the value. Okay, therefore work done is equal to minus PE cos of theta 2, that is scalar product P dot E. This is the work done. Okay, this work done is stored as potential energy, that is E is equal to minus of P. Okay, the amount of potential energy. Clear? Thank you.